This lesson is for Advanced Algebra, Lesson 3-2 on linear combinations, also called standard form for linear equations. So linear combination is the name of the equation that we're going to be focusing on today. And that equation is ax plus by equals c. When an equation is in this format, it's also sometimes called standard form for a linear equation. So know that ax plus by equals c is always going to form a straight line when you graph it. But in contrast to the slope-intercept equation, the a value, the number in front of x, is not the slope, and the b value here next to the y is not the y-intercept. Now it will have a slope and it will have both an x and a y-intercept when you graph it, but those values are not easily identified from the equation itself. That's not the purpose of the equation. Notice that the way that it's set up, the two variables that you're working with, x and y, will be on the same side of the equal sign, and the a, b, and c will simply be representing numbers. How do you know when to use this particular equation? Typically it's when you're trying to compare or take two quantities and add them up to equaling a total amount. Keep in mind that you don't always have to use the variables x and y. You can use whatever letters match with whatever equation or whatever situation you're working with. In general, when you're doing a graph of a line, keep in mind that the graph can be discrete, meaning it has dots on it only that are not connected, or it can be continuous, which means the dots are connected. So here's our first example. Zucchini sells for 49 cents a pound and tomatoes sell for 59 cents per pound. Write an equation using z and t for the amount you can buy for $5. So we have two quantities here that we are comparing. So we're going to utilize our two variables of z and t and we're going to add them together. Since each type or each variable has a differing amount, we're going to include that with each. Since some of the numbers here are in cents and the other ones are in dollars, I'm going to make the cents into a decimal. And for the t here for tomatoes, I'm going to say 0.59. Together, they're going to add up to $5. So this is a linear combination situation because we have two quantities that we're combining to equal a total. Again, keep in mind here that the 0.49 is not the slope and the 0.59 is not the y-intercept. Those things are simply just the setup for the equation. They are not how we're going to graph the equation. Keep in mind that there is no clear indicator here of which variable is which. It's not easy for us to be able to identify if the z is the independent or the dependent variable. There is no way of determining that, so you would have the option to make either variable either one. So you could make the z match with your x or your independent variable and your t match with your dependent, and if you had that flip-flopped it would still be okay. If the question does indicate which one should be the independent or the dependent, pay attention to that, but usually there is no direction given. So it's very important for students to be able to tell the difference between slope-intercept form, which is y equals mx plus b, which we covered in a previous day's lesson, and standard form or linear combination, which is the one we're focusing on for today. In the design of a word problem, there's typically some clues that help you figure out which equation format you should be using. In particular with the slope-intercept form, typically they'll give you a statement of fact of a simple number that you should be starting with, and that's usually your b value. And then there will be a constant increase or decrease that's mentioned in addition to that. So this was the water tank question that we had done yesterday when we talked about slope-intercept. It has a b value of 100 and a constant decrease value of a half because the tank is losing water every day, and so that's our slope. So that one lends itself to being a slope-intercept equation, whereas our zucchini problem from today has two quantities that we're comparing, so we add those together like we had done up above. So it's very important for students to recognize which type of word problem they're being given so that they can write their equation successfully. So try to think about, is the problem I'm working with a water tank problem or is it a zucchini problem? We're going to do one example out of the book because this lends itself to a question out of the homework. So first let's just read the question. Suppose a chemist wants to mix X liters of a 2.5 moles per liter solution of acid with Y liters of a 7.25 moles per liter solution in order to obtain a mixture with 10 moles of acid altogether. Write an equation that relates X and Y and the total number of moles. So we're just going to take X with the amount of mole solution that provides, and we're just going to stick those right next to each other. And we should be using an X here. And we're going to add it to the other mixture, which is 7.25 for Y. Together, it's going to make the total, which they tell us is 10. In part B, it says how many liters of the 7.25 moles per liter solution must be added to 1.3 liters of the 2.5 moles per liter solution to get 10 moles of acid in the final mixture. Round your answer to the nearest tenth of a liter. So we're going to utilize our equation, and in place of either X or Y, I'm going to put a blank space. The question is giving us either the X value or the Y value, and we need to read carefully and critically to figure out where the 1.3 should go. It says how many liters of the 7.5 should be added to the 2.5 solution. So that means the number they're giving us here is an X value. We have 1.3 liters of the 2.5 solution that we know of, but we don't know how many liters of the 7.5 solution we have. So we would simply calculate now to solve for Y. Students can go ahead and calculate here by multiplying, adding the opposite, and then dividing. Students can try that now on their own, and then I'll shortly provide the answer on the video. So you can see here that I multiplied together to get 3.25. I added the opposite of that to both sides to get the 6.75, and then divided by 7.25 on both sides to get the 0.9. I remembered to round to the tenth. I had 0.93. The 3 tells me not to round up, so I left it simply as 0.9. And then I labeled with an L for liters. We need this information to answer question number 6 in the homework. They want us to fill in the blanks for this statement. The point 0.8, 1.1, is an approximate solution to the equation 2.5x plus 7.25y equals 10. This solution means that you used about how many liters of the 2.5 solution and about how many liters of the 7.25 solution, with a total of about how many moles of acid. So they simply want us to place these values in the proper position in the statement. So the 2.5 moles per liter solution refers to the X value. So we would say 0.8 here. And the 7.25 refers to the Y portion, and so that would be a 1.1. And we already know that the total is going to be about 10. To figure out the domain of this question, we'd want to graph it in some way as one option. And so I'm going to take the equation and I'm going to modify it so that I can easily graph it on my graphing calculator. The best way to do that is to solve for Y. So I'm going to quickly do that on the video and fast forward a bit here to speed things up. So I went ahead and subtracted 2.5x from both sides, and then I divided by 7.25 everywhere, and I got some decimal answers here. So now I'm going to go ahead and type that in on my graphing calculator, and I'm going to get a graph for what that looks like. And so when I typed that in on my graphing calculator, I got a picture that looks approximately like this. Since I'm dealing with real life numbers here, I really only care about the values that are in quadrant 1. So I used my trace function on my calculator to identify where it crosses the x-axis. And it looks like it crosses a little bit past 4. And again, because they're asking me for the domain, I only worry or care about the x values here, or the values on the horizontal axis. So really the domain here is just going from 0 to 4. Anything beyond the 4 is going to be a negative y value, and that wouldn't make sense in this situation. So the domain here is simply going to be x such that x goes in between 0 and about 4. Now if you have that number on your graphing calculator as a more exact value, like 4.06 I believe it is, that's a better answer to have. For the sake of the video here, I was simply just being simple and quick and just rounded the number off. think we have further questions to answer here. Finally, we need to figure out what is the y-intercept and what does it represent. So let's move this up a little bit here. And let's see if we could answer that question. The y-intercept is going to be up here on our graph, and in our equation it's going to be that 1.38. So because that value is a y value, again, that's telling us, first of all, let's write what it is. It's the 0 and then about 1.38. And that number is telling us how much of the 7.25 moles per liter solution we can use. Because remember, that y value is coming from that portion of the equation. And so the equation is referring to the y value that goes with the 7.25 solution. I knew that students may struggle with that question, so that's why I wanted to include that one in the video. And I wanted to help students with number 6 because it relates to that example from the book.